Hello everyone, welcome to the channel Understanding Concepts of Physics. And in the latest video till yesterday, we have seen that we have finished off the topics of oscillation. Depending upon your board, there might be some topics which would be extra for you, some might be absent as well. In case if I have missed out some of the topics, then you can just comment me in the section, and I'll just be happy to make a separate video on the topics which I missed. So today we are starting with numericals on oscillations, and you can see the first numerical on the screen, which is you might have already read. At what distance from the mean position is the speed of particle performing S.H.M half its maximum, given the path length of S.H.M as 10 centimeters? The answer has also been given. So let's just quickly start with this very easy numerical. At what distance? So they are asking what distance it is. So that is when they are asking displacement and from the mean position. So displacement is always measured from the mean position and is the speed of the particle. So the velocity, they're talking about the velocity, which is half of its maximum, and the path length is 10 centimeters. So this path length is basically your the total distance from extreme to extreme. So let's say if I have a particle which is oscillating between these two extremes, this is the mean position, this is the positive extreme, and this is the negative extreme. So a particle which is oscillating like this, so the path length is given as 10 centimeters. So because it's going from negative extreme to the positive extreme, the path length is 10 centimeter. The amplitude would be 5 centimeters, the half of the full value. Okay, so I'll write whatever things are given. They have said the velocity of the particle at one particular position is half of maximum velocity. Now, if you have seen the videos, you will understand that velocity is maximum at the mean position, and the velocity at this any position, it would be something less than the maximum velocity, and at the extreme position the velocity is going to 0. So they are saying where is the velocity half of its maximum velocity? Path length is given as which is 2a is equal to 10 centimeters. Amplitude will come out to be as 5 centimeters because 2a is equal to 10, so a is equal to 5. They are asking displacement. Now remember my words that if in oscillation, if they are asking you to find out displacement or velocity or acceleration, then they will always mention one or the other quantity. Either they will ask you okay, after this much time, what is the displacement, what is the velocity, what is the acceleration, or they will ask you velocity when the displacement is so much, or they will ask you acceleration when the displacement is so much, or they will ask you displacement when the velocity is so much. That means always there will be an attached condition, because velocity, acceleration and displacement are different at different locations in simple harmonic motion. So we'll use the given condition, we'll apply the formula for both of them, velocity as well as maximum velocity, and we'll solve till we do not get x. So the given condition is v is equal to half of v max. Now you all know that the formula for velocity in oscillation is omega root of a square minus x square, and the maximum velocity ka formula is omega into a. We have derived these equations in previous videos. Then we have cancelled omega, so omega gets cancelled, and what remains is root of a square minus x square is equal to half of a. So omega is getting cancelled. From here on I'll square it, so squaring on both the sides. So when you square on both the sides, the root and the square will get cancelled out. So what remains is a square minus x square, and when you square it, one square is 1 and 2 square is 4. A square is as it is. Now the most key mistakes which we have been seeing in students is when they square it, they do not out of forgetfulness, like they just missed out this squaring this 1 by 2. 1 by 2 will become 1 by 4. Then comes this terms I am taking on this side, so that will become minus, and this minus x square I am taking on this side, so that will become plus. Then comes 4 ones are 4, so this is 1, there is nothing is there, means there is 1, so 4 ones are 4, 4 minus 1 is 3, so 3a square by 4, which is equal to x square. So in order to find out x, what you take is you take a root, so the root of everything, so root of 4 will be 2, and a square and root will get cancelled, root 3 we can't help, so what remains is root 3a by 2. This is what remains as x. Now I can solve that value for this by putting the value of root 3 as 1.732. In case if you remember this value, it's good. If you do not remember this, probably sometimes question paper may this will be mentioned. If your board allows logarithm, you can use by logarithm. If calculator is allowed, then that's one of the best parts. A is given as 5 and 2 is as it is. Then we have cancelled this. 2 ones are 2, 0.866, so into 5. So 5, say if when you multiply, we get 4.33 centimeters. So when if you see the physical significance of this problem, if this is my oscillation, this is 0, this is 5 centimeters, because they have mentioned the amplitude is 5 centimeters. So when the displacement is almost at this point, 4.33, this is your 4.33, this is where the velocity is half of maximum. So can you just imagine, this is your maximum velocity, where the velocity is maximum, and when the displacement is at this almost like we are just reaching like almost like 90 to almost like 80% of the reduction in velocity comes in between this region. Okay, so that's what the physical significance of this numerical is. So velocity will become half only when it is traveled 4.33 centimeters, and only at the last part, only at the last end of the oscillation, the velocity comes out to be 0. So the decrease in the velocity from 4.33 to 0 will come in the last part of the section. Okay, so this is where the velocity decreases. Okay, thank you so much for watching. Have a nice day. Subscribe the channel in case you have not done so. Keep watching the videos. More videos on numericals of oscillation will follow. Thank you so much. Have a nice day. Bye.